In this video, I'll go over how to use expressions in MyAssays Desktop. Expressions can be used throughout MyAssays Desktop to provide additional flexibility in data analysis design and configuration. An expression is simply an operation to be computed. It can refer to a sample or position, or it could specify mathematical or statistical operations. MyAssays Desktop's expression system provides custom analysis using a mathematical syntax that's similar to Excel, so it's easy to use. A couple of quick definitions to get started with expressions. An operator refers to a mathematical calculation, like addition, subtraction, multiplication, or division. An operand is what the calculations are performed on, like a number or a variable. Variables can refer to matrices, positions, or samples. Functions are more complex mathematical or statistical calculations. These are simple ways of performing more difficult analyses, like for example, PCV will perform the percentage coefficient of variation calculation on the specified operand, taking the ratio of the standard deviation and the average and multiplying it by 100. TOVs are transform output variables. These allow you to reference specific results that are computed by certain transforms. For example, if you have a standard curve fit transform as the first transform, it creates several parameters as a result of the transform analysis. If you're using a 4-parameter logistic curve, you can refer to the 4 parameters A, B, C, and D created by the analysis, the R-squared, and other outputs of the transform. So TOV1.R2 would reference the R-squared of your curve fit. It is useful to be able to refer to these results for further analyses, for example, to validate that a curve fit is within the required range. In the simplest case, an expression can refer to a numerical value, measurement, or result. You'll notice the syntax is very similar to Excel, but the column and rows match the microplate layout. So A1 refers to the row A and column 1 instead of the other way around. This is independent of plate layout. By using position, the expression will always refer to well A1, regardless of what sample type it contains. If your assay uses a rack layout, you can use the same syntax to refer to a tube position. Each rack is denoted using a letter, showing the row, and each tube position is designated by a number for the column, similar to a microplate layout. For example, A1 would refer to the first tube in the first rack, while B3 would refer to the third tube in the second rack. On the other hand, referring to sample groups will allow you to specify the sample group of interest regardless of where on the plate it is located. So I can use Control 1 as my operand, and in the example on the left, it will refer to wells H1 and H2. And in the example on the right, it will refer to wells F1 and F2. This is normally preferable to using a positional operand because in this case you will not have to rewrite your expressions each time you change the plate layout. This is a major benefit to using MyAssays Desktop when compared to a spreadsheet. With MyAssays Desktop, you can easily apply a different sample layout without needing to amend your expressions. A sample group reference will normally have context. For example, when used in a transform, it will refer to the sample on the input matrix. For multiple plates, it will apply to the sample on the plate being evaluated. An important note, for multiple plates, group references are always 1-based. You can also use an expression to refer to an entire sample type. For example, the unknown group would refer to all of the unknowns on your plate regardless of the plate layout. When working with assays with multiple containers, you can refer to a particular position or sample on a specific container. Containers refer to different plates or analytes in a multiplex assay. The format for referencing these specific positions is position or sample, followed by a period, matrix, followed by a period, and then container. So to refer to Control 3 on the second matrix of the first container, the reference is Control 3.2.1. The unary and binary operators and their corresponding operations will likely be familiar. A minus sign before the operand will add a minus sign. A plus sign between the two operands will perform addition. Minus sign between two operands performs subtraction. An asterisk performs multiplication. A forward slash performs division. And a caret raises the operand to a specified power. There is a comprehensive list of functions available by clicking Help or opening the User's Guide, but I'll go over some of the more common ones here. ABS will return the absolute value of the operand in parentheses. The average or mean will take the average of the operands in parentheses. In order to reference more than one operand, as we have in this example, use brackets around the multiple operands. You can use something like average of unknown 1 or mean of unknown 1, but that could simply be written as unknown 1 because that syntax already refers to the average of that sample group. This syntax will work for all of these listed functions. PCV will return the %CV, SD will return the standard deviation, SE will return the standard error, sum will return the sum, and VAR will return the variance. Expressions also allow you to specify logical functions. These are particularly useful in validations, flagging, and sample label conditions. These use a Boolean format, meaning the output will either be true or false. We could, for example, set up a sample flagging rule using the OR example, which would flag all samples less than 5 or greater than 10. The if-then-else function works similarly to the logical functions in Excel. You'll first need to define a Boolean condition to evaluate that will return either true or false. You'll then define the result if the condition was true, then the result if the condition was false. In this first example, we're evaluating if the value of unknown 1 is greater than 10. If it is, the result will show 10. If it's not, the result will show the value of unknown 1. This conditional function is a great way to define different calculations to be performed on different samples by using the position function to query the sample at each position. In the second example, we'd like to multiply the first replicate of the sample by 0.5 and all the other replicates by 0.125. To do this, we can use the if-then-else function in conjunction with the pause replicate function to evaluate the replicate number. If it's equal to 1, meaning it's the first replicate, it'll be multiplied by 0.5. Otherwise, it's multiplied by 0.125. Expressions can be used throughout the software to allow you to customize your data analysis design and configuration. They can be used in transforms such as expression by matrix dual, expression by position, and expression by sample type. They can also be used in validation tables and evaluation tables. For more information on the utility of expressions in each of these different applications, please see the subsequent videos in this training module.